Alright, we're going to continue our lesson on rational functions. In our last video, we just looked at how do we find vertical and horizontal asymptotes. In this video, we're going to look at how do we graph a rational function. So I'm going to give you some guidelines for graphing rational functions. Now, these guidelines are as follows. We're going to first have to start this by saying let f of x equal n of x over d of x, where n of x and d of x are polynomials, and d of x is not the zero polynomial, meaning d of x can't equal 0. So, then we can use the following things to graph. First, we are going to simplify f if possible, listing any restrictions, which are just values that would make our d of x equal to 0. Then we're going to find and plot the y-intercept, if there is any, by evaluating f of 0. So we're going to just plug 0 in for x and solve it. Then we're going to find zeros of the numerator to plot the x-intercepts. Again, if there's any. And you can use your calculator to do that. Once we've done that, we're going to find zeros of the denominator to sketch any vertical asymptotes. Again, if we have any. We're almost there with these guidelines. Next, we are going to find and sketch the horizontal asymptote, if we have any. Then we're going to plot at least one point between and 1 point beyond each x-intercept and vertical asymptote. And then the last thing you're going to do is you're going to connect the points with a smooth curve between and beyond the vertical asymptote. So let's look at an example on how we would actually do this. So we, in example 2, are looking to graph f of x equals x squared minus 9 over x squared minus 2x minus 3. So, first what we need to do is we need to simplify this. So let's start by factoring our numerator and our denominator, if we can. And here we actually can do that. So x squared minus 9, that factors into an x plus 3, x minus 3, because it's a difference of squares. In our denominator, when I'm factoring, I ask, what numbers do I know that multiply to make negative 3 that add to make negative 2? Well, negative 3 and positive 1 do. Now I notice then in my numerator and denominator I've got a common factor, so I'm going to eliminate it. But I do need to keep in mind that x cannot equal 3, because if it did, we would still have a little issue in our function. So now what we can do is gather up all the information we need. We need to find the y-intercept. Now to do that, we're going to just put 0 in for f of x. So we're going to take 0 plus 3 over 0 plus 1, which is going to make 3 over 1. So our y-intercept is going to be the point 0, 3. Now we're going to find any x-intercepts. To do that, based off the guidelines we wrote down before, we're going to just find what values make the numerator 0. So we're going to take x plus 3 and set it equal to 0 and solve for x. We're going to subtract 3 and find that x is equal to negative 3, which means our x-intercept is at the point negative 3, 0. And we've almost got all the information we need. We need to find our vertical asymptote, if there's any, and any horizontal asymptotes. So let's find our vertical asymptote. So to find that vertical asymptote, remember, we need to look at our denominator and figure out for what values of x would we get 0. So we're going to take x plus 1, set it to 0, and we're going to find we have a vertical asymptote at x equals negative 1. Which means when we're graphing, we're going to put a little imaginary line. We're just going to make a dashed line through x equals 1 that goes up and down. Now let's also find our horizontal asymptote. Remember, with our horizontal asymptote, we look at our leading terms in our problem. We've got x squared and x squared. The coefficient to both of those is 1, so since they're the same, we're going to divide them. Not since those coefficients are the same, but since the power on that x is the same, we divide their coefficients. So our horizontal asymptote is going to be the line y equals 1, which means when we make the graph where y equals 1, we're going to put a horizontal dashed line through it to represent that this is a line that it cannot cross. So let's start by sketching this graph. Okay, so we're going to start by making our x and our y axis. And then labeling, we've got 1, 2, 3, and if we at least label enough to see how much we're going by, our scale, then that's fine with me. Alright, so let's graph the important information we have. what we know is we have an imaginary line where we can't cross at y equals 1. So I'm going to put a dashed line through there. And all that means is when I do graph all my points, I'm never going to cross my line, my curve will never cross that purple dashed line we just made. We're also going to graph that vertical asymptote, which is x equals -1, so we're going to put a dashed line right there, and I'm doing mine in green. We also know a couple other pieces of information. We know that our y-intercept is at the point 0, 3, so we can go and put a point there. And we also know we have an x-intercept at -3, 0, so we can put a point there. Now, what we need to do is we need to then pick a point that is between and beyond the intercepts and the vertical asymptotes. And really, all I'm going to do is I'm going to pick an x value that's to the left and the right of my two asymptotes. So first here in red, I'm going to find f of, well, an x value that's to the left of -3. Let's just do -4. If we plug -4 into our function, -4 plus 3 over -4 plus 1, -4 plus 3, that is just -1. And -4 plus 1, that's -3, which means we're going to get 1/3 when x is -4. So I'm going to go and kind of estimate where I think that spot is. And I'm going to put a point right there. I'm also going to pick a point that is to the right of -3. So maybe I do -2. But before I do that, I'm going to erase what I just did with this -4 so I have space. So let's find f of -2. If we put -2 in, we're going to get -2 plus 3 over -2 plus 1. Well, -2 plus 3, that is +1. -2 plus 1 is -1. 1 over -1 makes -1. So at -2, the x value, our y value is -1. So I'm going to put a point there. And I've found a point to either side of that intercept. Now I'm going to connect those. When I'm going to the left, I can never actually cross that purple line. And when I go to the right, I can get close, but I can never actually touch that green line. So we've graphed part of it. Now let's do all this again, but we're going to pick values that are to the left and right of our y-intercept, our other point. So our y-intercept, the x value is 0, so let's pick a y value that's to the left of 0. And we can't do -1, so how about we just do a half? So we're going to look for f. In fact, I'm going to do this in blue, since blue is what I used for that intercept. We're going to look for f of -half, because that is to the left of 0. So we're going to take, and I'm just going to write 0.5. So -0.5 plus 3 over -0.5 plus 1. And what's that going to give me? It's going to give me 2.5 over 0.5, which if we just were to plug that into a calculator, it's going to give us 5. And really, We don't even need a calculator to figure that out, but you go ahead, use one, it's fine. So at x equals -1/2, our y is going to be 5. We're going to put a dot there. And then we're going to do the same process, but we're going to pick a value that is to the right of 0. So maybe we do f of 1. So we're going to go 1 plus 3 over 1 plus 1. 1 plus 3 is 4. 1 plus 1 is 2. And 4 over 2 equals 2. So when x is 1, y is 2. Now, something we do know, when we connect our dots here, making a nice curve, when we get to the x value 3, we have to draw a circle there. And all that says is we know x can't equal 3. And we've finished graphing this rational function. Now we're not done with this lesson on rational functions, but I'm going to save the last topic and our last example for our next video, because this was a lot for one video. We'll talk about slant asymptotes in our next video.